Hello guys. Hello everyone. Yeah, I've put up something in the chat box. Go check it out. अपना नाम, year and the department name. Go and put it up. So yeah, guys, we should start. So let's greet everyone. Good morning. Yeah, sorry. Good evening. And I need some voices. If you could, कोई अपना माइक ऑन करके हेलो बोल सकते हैं?
यो
या यो बचे लोग एटलीस्ट GDSC. अदरवाइज चैट में हाय बोल दो if you can't.
हेलो
Hey, hi, how you? Hi, Mayank.
ऐसे रिस्पॉन्ड किया करो, तुम लोग यूट्यूब पे हो, स्ट्रीम हो रहे हो, थोड़ा सा लाइक पब्लिसिटी हो जाएगी तो किया करो।
नमस्कार।
Sanika, Adinath. Yeah, quickly guys. सबका हाय चाहिए मुझे. Hi Om, hi Shantanu, Devyani, Uruj, Vidhi. You could like on your mic as well. Hi Govind. Hi, Aman. So, yeah, I think we've got the consistent count of 40-45 people. It will be 50, I guess, in 5 minutes. But let's not waste time starting the session. So, guys, आज क्या क्या होने वाला है? If you know, लास्ट सेशन में बताया था, तो किसी को पता है तो बता दो. What do you know? आज क्या क्या होने वाला है? क्या सीखना है तुम्हें आज? आगे की चीजें. वाह, that's an answer. यही आंसर एक्सपेक्ट कर रहे थे हम भी. चलो. So yeah, we'll be learning today. The topics are the sorting algorithms that are left. We are not covering everything, the every sorting algorithm, but the sorting algorithms that are commonly used, that are being asked on in the interviews or in placements. So the remaining sorting algorithms like quick sort and bubble sort will be covered today. And after that, the first half would be taken by Arpita Sawant, the B student from computer. Then the second half would be by Harsh on the topic of linked list. So you are getting you're gonna be learning these two topics today. So yeah, guys, about the last few sessions we had, किसी को कोई doubt है अभी तक? Like from the start, the first session till the last session we had about the sorting algorithms and searching. So if you have any doubts, come up and ask me right now. कोई भी हो, like coding related या फिर theoretically, any doubt, if you like could put up in the chat box also, or you could ask me directly. So I guess indirectly you're saying to let's just start the session, right? But today's session should be interactive, guys. So like I am putting up the cameras for the mentors as well. They will be like out there. You will be seeing them. Also, you should turn on your mics and give the responses. Yeah, yeah, you could give that. किसी को कोई प्रॉब्लम हो इंग्लिश से या फिर एनीथिंग लाइक दैट, you could ask us. Mostly we are preferring to use Hindi because that language could be like understood by everyone. That's why. Still, if you have any doubts or any queries or any feedback, we are appreciating them. So let's not do our work and we'll be starting. So आज के लिए we'll be starting with the sorting algorithms and it will be taken by Arpita. So Arpita, are you there? So yeah, guys, we'll be starting with the sorting algorithms. So if you have any doubt, come up and ask me right now about the previous sessions. And if not, we'll be starting. So yeah, Arpita, take over and we should start now.
Yes. So, hello everyone. I am Arpita Sawant from BE Computer. So, start करने से पहले आप पेपर और पेन ले लीजिए क्योंकि आज सॉल्विंग का है, क्विज का कुछ सीन नहीं है.
At least thumbs up से like respond करो if you're doing that what she says. Yeah, Pita, you should start.
So starting with the sorting algorithm, ओरिज ने एक्सप्लेन किया था कि लाइक सॉर्टिंग एल्गोरिदम क्या है करके. मैं एक शॉर्ट डेफिनेशन दे दूंगी. Sorting algorithm are a set of procedures used to arrange elements in a specific order. They are fundamental in computer science and data analysis. Basically क्या है वो मतलब algorithm में जो sort करते हैं unsorted array को. So ये एक मीम है लाइक कैसे मतलब सॉर्टिंग एल्गोरिथम्स वर्क होता है. सिलेक्शन सॉर्ट आप देख सकते हो कितना स्लो होता है. बबल सॉर्ट है. मर्ज सॉर्ट थोड़ा फास्ट होता है कंपेरेटिव टू सिलेक्शन सॉर्ट एंड बबल सॉर्ट. काउंटिंग का अपना कुछ सीन नहीं है तो उसकी जगह हम क्विक सॉर्ट ले सकते हैं. क्विक सॉर्ट वो बेस्ट सॉर्टिंग एल्गोरिथम माना जाता है. So next is so starting with the bubble sort. Bubble sort is a simple and initiative sorting algorithm. It works by repeatedly swapping adjacent elements if they are in a wrong way. तो बबल सॉर्ट वर्क कैसे करता है. वो दो चीजों से वर्क करता है. एक कंपेयरिंग एंड स्वैपिंग से और एक रिपीट अंटिल सॉर्टेड. कंपेयरिंग स्वैपिंग मतलब क्या कि वो फर्स्ट एलिमेंट कंपेयर करता है नेक्स्ट एलिमेंट से कि अगर फर्स्ट एलिमेंट ग्रेटर है नेक्स्ट एलिमेंट से तो हम उधर ही स्वैप कर देंगे. और ये कब तक होगा जब तक हमारा एरे सॉर्टेड नहीं बन जाता. तो उसका एग्जांपल है. सो ये फर्स्ट जो दिखाया गया है वो अपना अनसॉर्टेड एरे है. सेकंड जो है वो सॉर्टेड एरे. वो कैसे बन गया यूजिंग बबल सॉर्ट वी विल सी दैट. सो फर्स्ट पास में क्या होगा कि हम कंपेयर करेंगे ईच एलिमेंट को और अगर वो एलिमेंट ग्रेटर है तो हम स्वैप करेंगे. तो फर्स्ट में क्या है 77 एंड 44 है. अब सबको पता है कि 77 ग्रेटर है 42 से तो उधर क्या होगा स्वैप होगा. सो स्वैप हो गया वो नंबर. ठीक है. सो नेक्स्ट इटरेशन वो ith पोजीशन +1 होगा और जाएगा 77 पे. तो वो कंपेयर करेगा 77 35. अभी 77 35 क्या है वो भी 77 ग्रेटर है 35 से. सो वो भी स्वैप हो जाएगा. सो सेम फॉर 12 वो स्वैप हो जाएगा. और अभी 77 एंड 101 इसमें ग्रेटर कौन सा है 101. तो इसमें स्वैपिंग का कुछ सीन नहीं है. स्वैप नहीं होगा तो एज इट इज सेम रहेगा. सो कंपेयर करेगा नेक्स्ट एलिमेंट से. सो 101 एंड 5 इसमें ग्रेटर नंबर इज 101. लास्ट में 101 आएगा. सो बबल सॉर्ट क्या करता है वो बबल्ड अप करता है लार्जेस्ट एलिमेंट को और वो उस एलिमेंट को एंड पोजीशन तक लाता है. क्योंकि फिर सॉर्टिंग का मतलब क्या है कि लार्जेस्ट एलिमेंट शुड बी प्लेस्ड एट द एंड पॉइंट. सो इधर हमारा फर्स्ट पास में क्या हुआ कि जो अभी एरे में जो लार्जेस्ट एलिमेंट था दैट इज 101 वो आ गया लास्ट पोजीशन पे. राइट. तो ऐसे ही ये हमारा पास 1 हो गया. पास 1 में हमको पूरा एरे सॉर्ट करना पड़ता है. सो पास 2 सो इधर आ गया लार्जेस्ट वैल्यू करेक्टली प्लेस्ड. ओके. सो ये हो गया हमारा पास 1 का. और ये सेकेंड वन इज पास 2. पास 2 में क्या हुआ सॉर्टेड है 101 उसको हाथ नहीं लगाने का क्योंकि वो ऑलरेडी सॉर्टेड है और वो करेक्ट पोजीशन में प्लेस्ड है. सो सेकेंड में क्या होगा कि जो 42 है 42 फिर से कंपेयर होगा 35 से. फिर से स्वैप होगा. वो स्वैप होने के बाद इधर 35 आ जाएगा फर्स्ट पोजीशन पे और 42 सेकेंड. नेक्स्ट में क्या होगा 35 और 12 कंपेयर होगा. तो सॉरी 12 और ये 42 और 12 कंपेयर होगा तो 12 स्वैप होगा. सो वैसे इधर पासेस दिए हैं और लास्ट में हमें एक सॉर्टेड एरे मिल जाता है जब हम 5 और 12 को सॉर्ट करते हैं. ओके. सो ये समझ आया किसी को या कुछ डाउट है तो पूछो. सो अभी ये एक अनसॉर्टेड एरे है उसको सॉर्ट करना है यूजिंग बबल सॉर्ट. तो वो परफॉर्म करो स्टेप बाय स्टेप करो कि पास 1 दिखना चाहिए कि हाँ पूरा एरे सॉर्टेड है. पास 2 भी और पास 3 वैसे. और जो फर्स्ट 3 मतलब वो चैट्स में डालो कि डन हो गया करके. जिनका डन हुआ वो टॉप 3 हम रिकॉर्ड करेंगे नेक्स्ट इसके लिए। सो आप सॉल्व कर सकते हैं अभी।
Could you repeat the question again?
ओके, ये अनसॉर्टेड एरे, इसको सॉर्ट कर रहे हैं। Participants in a
Sort this, you need to use that sorting algorithm. So like we've seen the previous slides how it was sorted in the bubble sort. तो कौन सा एलिमेंट कब कंपेयर होगा ये तुम्हें ड्रॉ करना है, अदरवाइज यू कुड राइट द स्टेप्स। तो अरे एट ईच स्टेप कैसे दिखेगा, सो आई विल बी नीडिंग यू टू राइट दिस स्टेप्स। सो एक पेज भर के तो लाइक या देयर विल बी 6-7 steps और मोर देन दैट। So all these, with that, you click that photo from your page and put up in the DSA Bootcamp, otherwise GDSC ICOER group, and I'll be needing that. Okay, so whoever like puts up that first, that would be counted. So go guys. तो इतना इजी तो नहीं है कि हाँ ये सॉर्ट करना है, ये तो सबको पता है यार, दिस एलिमेंट इज द ग्रेटर और दिस इज द लेस एलिमेंट। It's not like that. You need to implement bubble sort there at first. Okay. समझ में आया अभी क्या करना है? सो लाइक थम्स अप कर दो। शुड आई एक्सप्लेन इट अगेन? नो राइट? Yeah, I'll be needing everyone to like put that in the groups. I need those screenshots or those pictures right now. Go and solve these on the paper, because unless you solve and dry run your like algorithms on the paper, you can't solve them in practically in the coding.
जिनका हुआ है वो चैट बॉक्स में डन कर दीजिए।
I need this solved in the papers. Okay, I need the photos on the group as well. If you're putting this in the chats, it's okay. Still, I need this in the group as well. So go and click the pictures and send over there. Okay.
Yeah, and if you have any doubt, then you can ask if anyone not getting.
बबल सॉर्ट का लॉजिक नहीं समझ में आया, आई विल बी एक्सप्लेन इट अगेन। सो पूछ लो अभी, we will explain it again, then you will do this, and I need pictures of everyone, like 44 people are there, I need everyone. सेंड ओवर द ग्रुप्स, इट्स फाइन, मुझे पर्सनली सेंड करने की जरूरत नहीं है.
सबका हुआ या नहीं इतना टाइम?
GCSJ पे ओनली एडमिन्स है क्या? GCSJ, हाँ सेकेंड ईयर, फॉर सेकेंड ईयर स्टूडेंट्स ना. एडमिन कौन है इसका? मोहित, इस पे सब पार्टिसिपेंट्स को सेंड करने का ऑथोरिटी देना.
हाँ, एक सेकंड.
Yeah, guys, we will be sending the second year people and third year people send it over the GCSJ T. Quickly, guys, everyone. Personally, बहुत सारे आ रहे हैं तो I couldn't be like सबका काउंट करना इजी नहीं जाएगा. So ग्रुप पे हो तो easy.
गाइस एक बार चेक करो, मैंने अनलॉक किया. हाँ.
तब ना वो क्या डी और प्राप्ति ने तो उस पे सेंड किया है ना.
हाँ, मैंने किया है.
Bro,
मैंने एससी का चेंज किया.
डी का है.
Nice one तो बहुत लोगों ने पढ़ा है. Photos are not like sent over there. I need photos on the either GDSC ICOER, either if you're belong like do you belong to like SC or TE. Apart from that, you will be sending over the GCSJ group, not on the community. Go and send it over there. So yeah, Arpita, you could continue. Let's go ahead.
ओके. सो ये सूडो कोड है बबल सॉर्ट का. इसका मतलब सॉर्टिंग का इतना पूछा नहीं जाता इंटरव्यूज में. पूछा गया तो सिलेक्शन सॉर्ट वैसे और क्विक सॉर्ट, हाँ वो भी एक इम्पोर्टेंट है, वैसे पूछे जाते हैं. सो मैं इसका सिर्फ लॉजिक बताऊंगी, आप इम्प्लीमेंट करो बाद में. सो इधर बेसिकली जिनको पता नहीं है सूडो कोड क्या होता है, वो बेसिकली अल्गोरिदम है, मतलब स्टेप से सो दैट लॉजिक क्लियर होता है एक कोड मतलब करने का. सो इधर हमने क्या किया है, फंक्शन डिक्लेयर किया है बबल सॉर्ट नाम का. उसमें हम इनपुट ले रहे एरे का, एन में हम लेंथ ऑफ एरे स्टोर कर रहे. फॉर लूप में हम क्या करेंगे, जो आई को हम इटरेट करेंगे 0 to लेंथ ऑफ लास्ट एलिमेंट लाइक n-1 तक। एक बुलियन वेरिएबल लिया हमने स्वैप नाम का, वो इनिशियली हमने फॉल्स किया क्योंकि अभी तक हमने एक भी स्वैपिंग नहीं की है एरे में। तो बाद में हमने फॉर लूप लिया है और फॉर लूप में जे को हमने इनिशियलाइज किया है 0 से। वो कब तक जाएगा? जब तक हमारा फर्स्ट पास इटरेट होता है तब तक। अभी हमने सपोज हमारा एरे ऑफ लेंथ है 4, ओके। सो 4 का क्या होगा? फर्स्ट लूप में जाएगा, 4 आई मतलब आई के लूप में जाएगा, तो वो कब तक चलेगा? 0 to 4 माइनस 1 कितना होता है? 3। तो 0 to 3 लेंथ तक इटरेट होगा वो फॉर लूप। तो उसके अंदर जे में क्या होगा? 0 to n-1 माइनस आई पोजिशन तक रन होगा। मतलब क्या? 3-1 माइनस फर्स्ट का आई का वैल्यू इनिशियलाइज हुआ तो 0, तो 0। तो वो फर्स्ट क्या करेगा? पूरा जो एरे वो इटरेट करेगा, उसमें फिर वो अंदर आएगा इफ एल्स में, इफ ब्लॉक में। इफ ब्लॉक में आने के बाद वो कंपेयर करेगा फर्स्ट एलिमेंट और उसका नेक्स्ट एलिमेंट। इफ फर्स्ट एलिमेंट ग्रेटर है नेक्स्ट एलिमेंट से, तो हम स्वैपिंग का फंक्शन यूज करेंगे। तो उस पे फिर स्वैप ट्रू हो जाएगा, क्योंकि मतलब सिस्टम को पता चलना चाहिए ना कि हाँ एरे अभी तक सॉर्टेड नहीं है। सो स्वैप का बुलियन वैल्यू टर्न हो जाएगा ट्रू में। और ये प्रोसेस चलता रहेगा जब तक हमको एक सॉर्टेड एरे नहीं मिलता। और जब हमारा स्वैप बुलियन वेरिएबल फॉल्स हो जाएगा, तब हमें पता चलेगा हाँ कि हाँ एरे सॉर्टेड है। तो उसके बाद क्या होगा? तो हम वो फॉर लूप ब्रेक करेंगे और रिटर्न में हम सॉर्टेड एरे प्रिंट करेंगे फिर से। किसी को इस कोड में डाउट है क्या? कौन सी भी लाइन हो, अगर हो तो पूछो अभी।
Sometimes then put no.
हाँ, पता तो चले समझ आ रहा है कि नहीं। सिर्फ 2, 3? ऑल क्लियर? अच्छा है।
तो पूछना था, ये कंपाइल पे किया हुआ है क्या? अगर देख सकते एक बार,
क्या क्या?
अगर कोई लैंग्वेज में किया हुआ है क्या कंपाइलर पे?
नहीं किया हुआ है। जो एक्चुअली मैं शेयर कर दूंगी, पीपीटी में है,
हाँ,
मैं बाद में शेयर कर दूंगी। लॉजिक सेम है, इसलिए मैंने क्या किया है, मतलब ये लॉजिक हम किसी भी लैंग्वेज में यूज कर सकते हैं। सो मैंने डिफरेंट लैंग्वेजेस यूज नहीं किए, सिर्फ एक ही में लॉजिक बता दिया। अब आपने इतना सब डीएसए किया है, सो फंक्शन डिक्लेरेशन तो आपको पता है, फॉर लूप यूज करना है वो पता है आपको, इफ एल्स ब्लॉक तो पता है। सो लॉजिक, अगर आपको लॉजिक पता होगा तो कोड भी आ जाएगा। अगर नहीं आया तो मैं हुई, आप पूछ सकते हो मुझसे। ये दिखा मैंने कोड क्यों नहीं दिखाया? क्योंकि ये पूछा नहीं जाता, इसलिए इतना। सिर्फ इम्प्लीमेंटेशन याद रखो कैसे करना है, अगर पूछा गया तो। या तो आगे जा सकती हूँ मैं, या और कोई डाउट है? सो बबल सॉर्ट की टाइम कॉम्प्लेक्सिटी, उसका बेस्ट केस है, आप देख सकते हो, बिग ऑफ एन है, एवरेज एंड वर्स्ट केस। So, starting with the quicksort. Quicksort is a fast and efficient sorting algorithm that works by dividing an array into smaller parts and sorting them independently. It selects a pivot element and arranges elements around it, moving smaller elements to one side and larger elements to the other side. This process is repeated recursively until the entire array is sorted. Quicksort is known for its speed and is widely used in many programming applications. As मैंने बोला है कि quicksort बेस्ट सॉर्टिंग एल्गोरिथम कंसिडर हुआ जाता है, क्योंकि वो फास्टेस्ट एल्गोरिथम है जिससे हम सॉर्टिंग फास्ट वे से कर सकते हैं और मतलब हो जाता है कंपेयर टू बबल सॉर्ट, सिलेक्शन सॉर्ट। उसका बहुत लेंदी प्रोसेस है। लाइक हमको ईच पास को सॉर्ट करना पड़ेगा, फिर बाद में n नंबर ऑफ पासेस मिलेंगे, बाद में हमको वो एरे का सॉर्टिंग मतलब फाइनल सॉर्टेड एरे मिलेगा। क्विक सॉर्ट में ऐसा नहीं है। इधर हम डिवाइड एंड कॉन्कर का स्ट्रेटेजी यूज करते हैं, जिसमें इजी पड़ता है कि ज्यादा टाइम नहीं वेस्ट होता और हमको रिक्वायर्ड आउटपुट जल्दी मिलता है। ये देख सकते हो आप एक मीम में कि मर्ज सॉर्ट, बबल सॉर्ट, इंसर्शन टेक अ मिनट ऑफ टू सॉर्ट था 1 lakh रैंडम नंबर्स, क्विक सॉर्ट डज इट इन 18 seconds। सो एक एग्जांपल है। सो पिवट वो एलिमेंट मतलब क्या होता है कि हम कौन सा भी एक रैंडम एलिमेंट सिलेक्ट कर लेंगे, मतलब वो कौन सा भी हो सकता है। आप मिडल एलिमेंट भी ले सकते हैं, फर्स्ट भी ले सकते हैं, एंड भी ले सकते हैं। इधर मैंने क्या किया है, एक एंड एलिमेंट लिया 13। सो मैं क्या करूंगी, अब 13 को कंपेयर करूंगी बाकी एलिमेंट से। जो नंबर मेरा पिवट से लेस होगा वो लेफ्ट एरे में जाएगा, और जो मेरा एलिमेंट पिवट से ग्रेटर होगा वो राइट एरे में जाएगा। सो अभी आप ऊपर देख सकते हैं 13 से लेस कितने नंबर है, 7 है, 12 है और 4 है। और 13 से ग्रेटर कौन से, 18 है, 18 है, 15 है, 19 है और 16 है। ओके। सो इधर क्या करना पड़ेगा, हमको पार्टीशन करना पड़ेगा। जब ये कब तक प्रोसेस चलेगी, जब तक हमको लास्ट में एरे में एक एलिमेंट नहीं मिलता और सॉर्टिंग मतलब सॉर्टिंग नहीं होता। तो अभी हम देख सकते हैं इधर हमने 13 लिया। सो नेक्स्ट में क्या करने का, उसमें भी एक पिवट सिलेक्ट करने का। सो हमने अब आप लेफ्ट एरे में देखें तो 7, 12, 4, 11 इसमें हमने फिर से हमने लास्ट एलिमेंट को पिवट कंसीडर किया। ठीक है। सो पिवट को हम इधर मिडल में रखेंगे और अभी चेक करेंगे 11 से लेस देन है क्या। हाँ है। कौन से लेस देन नंबर है, 7 और 4 है, तो हमने लेफ्ट में रख दिए। ठीक है। और 11 से ग्रेटर कौन से, 12 है, तो उसको हमने राइट में रख दिया। तो अभी भी सॉर्टेड एरे नहीं है, आप देख सकते हो लेफ्ट में दो एलिमेंट्स तो बचे। हमको कब तक ये सॉर्ट करना पड़ेगा, जब तक एरे में सिर्फ एक एलिमेंट नहीं बचता। सो 11 और 12 तो सॉर्टेड है, ठीक, क्योंकि उसमें अनदर एलिमेंट मेंशन नहीं है, प्रेजेंट नहीं है। बट लेफ्ट साइड में 7, 4 में है। सो उसमें फिर से हम क्या सिलेक्ट करेंगे, लास्ट एलिमेंट पिवट को कंसिडर करेंगे। सो 4 से लेस एलिमेंट है क्या, इधर नहीं है। 4 से ग्रेटर कौन सा है, 7। सो 7 को हम राइट साइड में शिफ्ट करेंगे। क्यों राइट साइड में, क्योंकि वो चेक करता है कि पिवट हाँ ग्रेटर देन पिवट है, तो वो राइट साइड में जाएगा। सो लेफ्ट साइड का पूरा हो गया सॉर्टिंग, मतलब जो आपने मेन 13 का लिया था पिवट, उससे लेस नंबर्स का पूरा स्मॉलर नंबर जो भी है उसका सॉर्टिंग हो गया। तो हम राइट साइड पे आ जाते हैं। तो राइट साइड पे हमने क्या देखा था, 13 से ग्रेटर कौन से, सो वो 18, 15, 19 और 16 है। सो एज यूजुअल हमने जो लास्ट को पिवट कंसीडर किया था, इसमें भी हम लास्ट को करेंगे। सो लास्ट को करने के बाद इधर क्या है, 16 है। सो मैंने 16 को कंपेयर किया बाकी एलिमेंट से, तो मुझे 16 से कम कौन सा एलिमेंट मिला, 15 मिला। ओके। और 16 से ग्रेटर कौन सा है, 19 और 18। तो अभी ठीक है, 15 सॉर्टेड है, 16 भी सॉर्टेड है, बट इधर 19 और 18 वो अभी भी सॉर्टेड नहीं है। सो फिर हम इसमें फिर से वो मतलब पार्टीशन करेंगे। पार्टीशन में अगेन पिवट एलिमेंट सिलेक्ट करेंगे। इसका 18 सिलेक्ट करेंगे। इज 18 ग्रेटर देन 19, नो इट इज नॉट। सो वो राइट साइड में शिफ्ट होगा। तो लास्ट में क्या मिलेगा हमें कि जो एलिमेंट सिंगल एरे में प्रेजेंट है आफ्टर पार्टीशनिंग, उधर हम एंड करेंगे हमारे लूप को। सो इधर हमें क्या मिला, 4, 7, 11, 12, 13, 15, 16, 18, 19, ये हमको अपना सॉर्टेड एरे मिल गया। ठीक है। इसमें कुछ डाउट है? बाकी को कि समझ नहीं आया? और ऐसा कंपलसरी नहीं कि हाँ एंड एलिमेंट को ही पिवट कंसीडर कर, हम रैंडम भी कर सकते हैं, फर्स्ट को भी कर सकते हैं, और अगर मिडल में लेना है तो वो भी कर सकते हैं। बट बेस्ट प्रैक्टिस इज सिलेक्ट बेस्ट एलिमेंट only.
The last one, the first one. Can you like anyone tell why not the middle element or any other element? थोड़ा लॉजिक लगाओ, कोई भी बताओ, if you can tell. We use last or the first element preferably, and why is that? मिडल एलिमेंट क्यों नहीं यूज कर सकते, या फिर रैंडम एलिमेंट क्यों नहीं यूज कर सकते?
अगर लास्ट वाला एलिमेंट्स को ले ले तो उसके बाद जो उसके पहले जो उससे कम है और उससे ज्यादा, उनको लेफ्ट राइट में डिफरेंशिएट करने में इजी हो जाएगा.
या क्वाइट, बट हम बीच वाले एलिमेंट्स क्यों नहीं ले सकते? इट कुड बी एनीथिंग ना, के भी छोटे एलिमेंट्स जो लेफ्ट में रख सकते हैं हम. लॉजिक थोड़ा उल्टा सीधा करके कर सकते हैं. There are two things, like one thing as Satyam mentioned कि अगर लास्ट एलिमेंट हो तो लॉजिक इजी पड़ता है, दैट स्मॉलर एलिमेंट्स शुड बी एट द लेफ्ट साइड, राइट, एंड द ग्रेटर एलिमेंट शुड बी एट द राइट साइड. तो करने में इजी जाता है, एक तो कोड इजी बनता है. सेकेंड थिंग, अगर तुम पिवट एलिमेंट फर्स्ट चूज कर रहे हो तो तुम डिसेंडिंग ऑर्डर में कर सकते हो सॉर्ट, दैट वुड बी इजी फॉर दैट वन. बट रैंडमली या फिर बीच वाला एलिमेंट क्यों नहीं चूज कर सकते? बिकॉज दैट एलिमेंट माइट बी टारगेटिंग twice in the code or thrice. Like if you're using some formula to calculate the random number in the array or the middle element, that could generate twice or thrice also. Like that element could be targeted twice or thrice. So उसमें time complexity ज़्यादा बढ़ जाती है. So we should like preferably use either first element as a pivot element, preferably for descending order sorting, and the last element for ascending order. So that's how it goes. Remember this point. You could like impress your teachers or someone with this. Yeah, Arpita, we should continue.
या सो मैं मतलब ये कोड आपको सूडो कोड से एक्सप्लेन करूंगी कैसे होता है. पहले हम उसका लॉजिक देखेंगे. सो स्टार्टिंग विथ मतलब क्लास डिक्लेयर किया हमने क्विक सॉर्ट नाम का. उसमें फंक्शन डिक्लेयर किया है क्विक सॉर्ट. उस पर हमने पैरामीटर्स पास किए एरे, लो और हाई. लो और हाई मतलब क्या? मतलब स्टार्टिंग पॉइंट और एंडिंग पॉइंट, ऐसा आप ध्यान में रख सकते हो. सो अगर हमारा स्टार्टिंग पॉइंट लेस देन एंड पॉइंट होगा तो ही ये इफ लूप चलेगा. अगर वो ग्रेटर होगा तो चलेगा ही नहीं ना, क्योंकि स्मॉलर हमारा क्या होगा? 0 है. सो 0 से कुछ कम हो ही नहीं सकता. सो इधर से स्टार्ट होगा. सो हमने इधर हम अपना पिवट इंडेक्स वेरिएबल डिक्लेयर किया है. उस पर हमने क्या पास किया है? ये पार्टीशन नाम का फंक्शन पास किया है. वो पार्टीशन नाम का फंक्शन क्या है मैं आपको बताऊंगी. सो बाद में क्या किया हमने? क्विक सॉर्ट इसी फंक्शन को हमने कॉल किया है कि फर्स्ट एरे पास किया है, उसका स्टार्टिंग इंडेक्स पास किया है, और जो पिवट -1 वो क्या है कि हमारा जो पिवट का इंडेक्स है उससे -1 मतलब -1 मतलब क्या? वो लेफ्ट साइड का जो भी एरे वो उतना वो सॉर्ट करेगा. इसका लॉजिक है ये. सेकेंड है एरे पिवट +1 से स्टार्ट किया है हमने. स्टार्ट क्यों किया? मतलब जो हमारा पिवट का एलिमेंट है उससे उसके आगे जो एलिमेंट है वो ग्रेटर देन पिवट के एलिमेंट्स होंगे, तो उससे वो पता चलेगा कि हाँ कि राइट साइड का है और उधर हम सॉर्ट कर रहे हैं. सो पार्टीशन कैसा होता है इधर देखेंगे हम. सो पिवट में हमने क्या स्टोर किया? मैंने बताया था उधर कि लास्ट एलिमेंट कंसिडर किया है. सो इधर भी मैंने लास्ट एलिमेंट ही पास की. आपकी इच्छा हो तो आप इधर लो भी पास कर सकते हो. मिडल एलिमेंट रैंडम एलिमेंट पास करना है वो भी कर सकते हो. मैंने इधर एंड का पास किया है और आई मैंने इनिशियलाइज किया लो -1 से. सो फॉर लूप में हमने क्या देखा है कि जे को हमने इनिशियलाइज किया लो से, मतलब स्टार्टिंग पोजीशन से, विच इज 0. वो लेस देन होना चाहिए एरे ऑफ लेंथ से, और जे प्लस किया है. इफ में हमने क्या पास किया है कि एरे ऑफ जे मतलब जो एलिमेंट है वो एलिमेंट लेस देन पिवट एलिमेंट होगा तो ही वो ये फॉर लूप रन होगा, नहीं तो नहीं होगा। तो इधर हमने क्या किया है, इधर जो आई की वैल्यू ली थी लो -1, इधर हम वो इटरेट कर रहे प्लस प्लस से। सो इधर हम क्या करेंगे, एक टेम्परेरी वेरिएबल लेंगे, उसमें अगर हमको ये पता चला कि हाँ जो मेरा पर्टिकुलर एलिमेंट है वो लेस देन हमारा पिवट एलिमेंट है, तो क्या करेंगे कि वो एलिमेंट हम टेम्परेरी में स्टोर करेंगे। ये स्वैपिंग टेक्निक है, आपको पता होगा शायद। सो वो टेम्परेरी में स्टोर करेंगे। सो अब हमारा एरे ऑफ आई तो एम्प्टी है, तो उसमें क्या स्टोर होगा, जो एलिमेंट हमारा लेस देन पिवट है वो एलिमेंट उस एरे ऑफ आई में स्टोर होगा। ओके, सो अब हमारा एरे ऑफ जे वो एम्प्टी है, तो उसमें जो टेम्परेरी जो हमने स्टोर किया था एरे ऑफ आई का एलिमेंट वो जे की पोजीशन पे स्टोर होगा। इससे क्या होगा कि वो स्वैप होगा, जो भी नंबर है वो स्वैप होगा उधर ही। और अगर सपोज हमारा एलिमेंट वो ग्रेटर है पिवट से, तो ये फॉर लूप रन ही नहीं होगा। तो ये फॉर लूप से बाहर आके वो क्या करेगा, टेम्परेरी वेरिएबल में एरे ऑफ i+1, ये एरे ऑफ i+1 क्यों दिया है, अब देखो अगर वो एलिमेंट तो ग्रेटर देन पिवट नहीं है तो क्या होगा कि जो एलिमेंट है आई पोजिशन पे वो i+1 की पोजिशन में कौन सा एलिमेंट होगा, पिवट का एलिमेंट होगा। तो वो उसका इंडेक्स हम टेम्परेरी में स्टोर करेंगे। और हमने पार्टीशन में देखा था कि हाँ फर्स्ट में हमने वो 13 को डिवाइड किया था, तो बाद में हमको क्या मिला था, लेफ्ट और राइट। अब हमें फिर से मतलब नीचे के एरे से हमको फिर से एक पिवट फाइंड करना है। तो वो कैसे फाइंड करने का, फिर से उस लेफ्ट और राइट एनीथिंग इट कैन बी, अभी नहीं सॉरी लेफ्ट का तो ये है, राइट का क्या करेंगे, जो लास्ट एलिमेंट है उसको हम एज अ पिवट कंसिडर करेंगे और वो इस पे स्टोर करेंगे। ठीक है, सो जो टेम्परेरी हमने स्टोर किया था i+1 की पोजीशन पे, वो इधर मतलब एंड पे वो स्टोर हो जाएगा, जिसकी इंडेक्स हमको रिटर्न करनी। और इधर फिर हम वो इंडेक्स रिटर्न करते हैं। फिर हमने इधर एक अनसॉर्टेड एरे पास किया है और एन में हमने लेंथ को स्टोर किया है, एरे ऑफ लेंथ को। तो पहले हम अनसॉर्टेड एरे प्रिंट करेंगे ये लूप से, फिर बाद में क्विक सॉर्ट का फंक्शन कॉल करेंगे और फिर सॉर्ट एरे पास करेंगे। मैं एक बार रन करके दिखाती हूँ। ये देखो हमको मिल गया हमारा सॉर्टेड एरे। तो ये तो हो गया कोड से। तो मैं एक बार सूडो कोड से बता दूंगी आपको। हाँ, तो जैसे हमने देखा था उधर फंक्शन डिक्लेयर किया था, ठीक है, एरे ऑफ लेंथ का लेफ्ट और राइट मतलब लो और हाई का डिक्लेयर किया था। तो अगर लो ग्रेटर लेस देन एंड होगा तो ही ये फंक्शन रन होगा। तो पार्टीशन में क्या होगा कि इधर पहले पार्टीशन करेंगे हम। सो एज यूजुअल मैंने उधर मेंशन किया था कि हमारा पिवट जो एंड एलिमेंट होगा एरे का वो स्टोर करे, वो कौन सा भी एलिमेंट हो वो स्टोर करेगा। सो हमारे इधर एलिमेंट है 7, सो 7 वो पिवट की वैल्यू होगी, उसमें स्टोर होगी। सो 7 हमने लिया, फिर लेस देन है वो लेफ्ट साइड में आएगा, कंपेयर करेंगे हम पिवट से, और जो पिवट से ग्रेटर देन है वो राइट साइड में आएगी। फिर नेक्स्ट फिर से अभी जो हमने रिटर्न किया था i+ वैल्यू, तो हमें पता चला कि हाँ एक बार तो हो गया, फिर से हमको देखना है ना कि एरे सॉर्टेड है क्या नहीं। तो फिर से हमको एक न्यू पिवट फाइंड करना है। तो किधर से स्टार्ट होगा, एंड ऑफ द एलिमेंट वेयर, मतलब जिधर एरे एंड होता है वो हम एज अ पिवट कंसिडर करते हैं। सो इधर लेफ्ट साइड में हमने 2 कंसिडर किया। सो 2 के लेस देन है क्या, कोई नहीं है। सो इधर एम्प्टी एरे है और 2 के ग्रेटर देन कितने, 6 3 5 है। सो अगेन फिर उसमें कंपेयर करेंगे, 6 3 5 में लास्ट का एलिमेंट लेंगे, 5 कंपेयर करेंगे, हाँ 5 लेस देन है, 5 ग्रेटर देन है 6 से और लेस देन है 3 से। तो इधर हमको मिल गया, लास्ट में मिल गया कि हाँ एरे में एक ही एलिमेंट है, तो फर्दर पार्टीशन होगा ही नहीं क्योंकि कोई एलिमेंट बचा ही नहीं। सो हम राइट के पास आएंगे। राइट पे क्या है 8 और 9, तो हम एज यूजुअल 9 को एज अ पिवट कंसिडर करेंगे। 9 को कंपेयर करेंगे, 9 के ग्रेटर कोई है क्या, नहीं है। 9 के लेस देन कौन है, 8 है। तो हमको सॉर्टेड एरे मिल गया अपना, जो है 2 3 5 6 7 8 9। तो ऐसे वो फंक्शन रन होता है जिसमें हमने ये पार्टीशन देखा था, जो फंक्शन को रन किया था। फिर ये जो है ये अपना लेफ्ट का जो एरे, उस पे ये फंक्शन वर्क होता है। और ये सेकंड वाला है वो जो राइट का ग्रेटर देन है, पिवट से ग्रेटर देन, उसका फंक्शन ये रन होता है। सो अगर किसी को डाउट हो तो पूछ सकते हो। सिर्फ मोहित को डाउट नहीं है, बाकी को है क्या? अगर है तो बताना, मैं फिर से एक्सप्लेन कर दूंगी। सानिका नो डाउट। बस 3, बाकी लोग क्या सो गए क्या?
सीरियसली गाइस, सबको पता है? सबको लाइक या शी इज टीचिंग सो वेल ना, सबको ऑल क्लियर है?
नहीं रे, इतना भी अच्छा नहीं पढ़ाती मैं।
कभी स्वैपिंग का फंक्शन राइट किया है तुमने कोडिंग, लाइक हाउ टू स्वैप टू नंबर्स और इन array something like that? Only two people?
किधर?
किया है राइट?
हाँ हाँ।
आई डोंट थिंक सबने किया होगा। मुझे हैंड रेस चाहिए जिन्होंने अभी तक लाइक सबको पता है स्वैपिंग फंक्शन क्या होता है। Then like they
नहीं पता तो मैं एक्सप्लेन कर दूंगी, वो तो बेसिक्स है।
I need hand raises जिन्होंने स्वैपिंग फंक्शन ट्राई किया है and they know how to like swap two numbers or something. Okay, come on guys, hand raise करो सभी, like जिन्होंने ट्राई किया है, जिनको पता है स्वैपिंग फंक्शन। बिकॉज अभी जो कोड तुमने देखा क्विकसॉर्ट का, इट ऑलमोस्ट इन्वॉल्व्स all it almost revolves
जो आपने यूज किया था ए और बी का लॉजिक, मतलब जिनका हुआ है स्वैपिंग, एलिमेंट्स मतलब कर सकते हैं हम वेरिएबल्स का स्वैपिंग, वैसे ही एरेस का भी स्वैप होता है।
So yeah, only 14 people have tried swapping there. Am I right? Only the 14 hand raises. So बाकियों को पता नहीं लाइक हाँ ये नंबर यहाँ से यहाँ पे कैसे गया। सपोज यहाँ 42 है, वो 8 से अगर स्वैप किया तो 8 42 की जगह पे आएगा and 42, yeah, they will be swapping in each other's positions. But जिनको ये पता नहीं, जिन्होंने कभी ट्राई नहीं किया like using temp variable or some or without using temp variable as well, that's a high level stuff. So अगर तुमने यूज नहीं किया अभी तक तो पहले वो ट्राई करो, like how to swap them, then you go on with the quicksort. Like you can see here, पहले quicksort के लॉजिक में क्या है यहाँ पे, like your partition, like partition नाम का एक फंक्शन है, उसमें हमने पास किया कुछ तो, but after that we are recalling the quicksort function, right? So इस कंसेप्ट को क्या बोलते हैं, किसी को पता है? Like we are recalling the function that we are implementing currently. इसको क्या बोलते हैं, किसी को पता है?
फंक्शन में हुआ है ना,
रिकर्जन।
Yeah, Mohit, Harsh, you are right. It's called recursion, and that's how we are like recursively calling the quicksort function. That's why it is getting implemented. तुम्हें like there'll be some questions कि हाँ ये कैसे implement होता है, how is it like ये पूरा sort करके कैसे देता है। So it's like basic logic है। पार्टीशन तो हो जाएगा, पार्टीशन के टाइम क्या हो रहा है, एक एलिमेंट अपनी सही जगह ढूंढ रहा है, ठीक है, उस टाइम वो क्या कर रहा है, इनमें से लेस जो एलिमेंट्स है उनको लेफ्ट साइड ढकेल रहा है, जो ग्रेटर है उनको राइट साइड ढकेल रहा है, एंड वो उनके बीच में जाके बैठ रहा है. सो ओनली द सिंगल एलिमेंट इज गेटिंग properly placed or properly arranged in the array at the time of partition. Okay, so ये पार्टीशन फिर से होना चाहिए बाकी एलिमेंट्स के लिए, राइट. सो नेक्स्ट टाइम क्या कर रहे हैं हम, लेफ्ट अरे को कॉल कर रहे हैं और उसमें फिर से पिवट एलिमेंट को हम अपनी सही जगह पे भेज रहे हैं, एंड फॉर द राइट अरे एज. सो ये लॉजिक रिपीटेडली रन हो रहा है, एंड देन विल बी गेटिंग द सॉर्टेड अरे. इट्स अ इजी लॉजिक बट यू शुड अंडरस्टैंड इट वेल, बिकॉज अगर तुम्हें लॉजिक समझ में आया तो इट्स ऑल अबाउट द स्वैपिंग फंक्शंस एंड इट्स द कोडिंग वुड बी लाइक सो इजी. So I think you should guide, like everyone should know what the logic behind this quicksort is. Okay, it's easy code, and if you know it, you will be like flexing. Yeah, I know the codes, how to sort or how to search anything. Searching and sorting, you should know these basic searching sorting techniques. You should by heart this. Okay. So if you have any doubt,
मैं एक बार बता दूं क्या उनको, मतलब स्वैपिंग का.
yeah, you could. I don't think they'll be asking maybe peer pressure or something like that. गाइस यहाँ पे लाइक लर्न कर रहे हैं ना, तो यहाँ पे वो सभी जीरो है, आई थिंक. तो इतना कुछ डरने की जरूरत नहीं. यू कैन आस्क द पीपल हु आर टीचिंग यू, दे आर ओनली क्लासमेट्स ऑफ योर्स, दे आर आल्सो लर्न. टोल्ड यू ऑलरेडी. या अभी ये बी के स्टूडेंट है, इसको ये नहीं है आपकी क्लास, बट या अदर पीपल हु टॉट यू. या अर्पिता, टेक ओवर.
ओके, मैं एरे का नहीं बताऊंगी, पहले सिंपल दो वेरिएबल्स को हम कैसे स्वैप करते हैं वो देखते हैं. पहले मैंने इनिशियलाइज किया ए को 10 से, सेकेंड वेरिएबल को हम 20 ले लेते हैं. सो ये टेम्परेरी वेरिएबल, ये मैंने बी क्विक सॉर्ट में यूज किया था. वो क्या है, अभी तक वो एम्प्टी है, ठीक है. मैंने कुछ मतलब उसको वैल्यू असाइन नहीं की. सो मैं क्या कर सकती हूँ, टेम्परेरी वेरिएबल को मैं, मतलब ए को मैं टेम्परेरी वेरिएबल में स्टोर कर दूंगी. सो मेरी अब टेम्परेरी वेरिएबल की वैल्यू क्या होगी, 10 होगी, राइट. सो अभी मेरा ए तो ए एम्प्टी है, तो मैं ए को ए में क्या स्टोर करूंगी, ए में अपना बी स्टोर कर दूंगी. अभी बी की वैल्यू क्या है, बी की वैल्यू 20 है, तो 20 मेरा कहाँ स्टोर हो गया, ए में स्टोर हो गया, ए वेरिएबल. तो अभी ए तो स्टोर हो गया, ठीक है. तो बी तो एम्प्टी है, फिर मैं बी को क्या करूंगी, बी को टेम्प के वेरिएबल में जो वैल्यू उसको स्टोर करूंगी. ऐसा क्यों किया मैंने, कि देखो पहले टेम्प वेरिएबल डिक्लेयर किया, ठीक है. वो तो पहले से एम्प्टी था, मैंने कुछ वैल्यू असाइन नहीं की थी. तो मैंने क्या किया, ए की जो वैल्यू है वो टेम्प में मैंने डाल दी. ए की वैल्यू में क्या था, 10 था, ठीक है. 10 को टेम्परेरी वैल्यू में डाल दिया, तो टेम्परेरी.
the output first, then tell them.
ओके, ये देखो स्वैप हो गया ना, 20 और 10. हाँ, तो ये कैसे हो गया मैं आपको एक बार समझाती हूँ. टेम्प हमारा एम्प्टी था, ठीक है. तो उसमें हमने क्या स्टोर किया, ए की वैल्यू वो हमने टेम्प में स्टोर की थी. तो ए की वैल्यू क्या थी, 10 हमने टेम्प में स्टोर किया, तो 10 की वैल्यू क्या होगी, 10 होगी. अब ए के पास तो कुछ नहीं, क्योंकि ए ने, ए के पास जो था 10 की वैल्यू वो तो टेम्प में गई. तो की वैल्यू क्या थी, 20 हमने ए में स्टोर किया. ये तो ठीक है, ए की वैल्यू असाइन होगी 20, तो बी तो एम्प्टी है. बी का क्या करेंगे, सो बी का क्या करेंगे हम, जो टेम्परेरी वेरिएबल हमने डिक्लेयर किया था उसकी वैल्यू हम क्या थी, 10 थी. और 10 किसकी वैल्यू, इनडायरेक्टली ए की वैल्यू है. सो हमने टेम्परेरी वेरिएबल को जो इसकी वैल्यू है वो फिर से हमने बी में डाल दी. तो स्वैपिंग ऐसे वर्क होता है. इधर हम देख सकते हैं 20 और 10 प्रिंट हो गया। अभी समझा? बाकी लोगों को? तो वैसे ही हमने इधर क्या किया है क्विक सॉर्ट में। सो इधर हमने क्या किया है, जो मतलब फर्स्ट एलिमेंट है एरे का, उसको हमने टेम्परेरी वेरिएबल में स्टोर किया। जो नेक्स्ट है उसको मतलब इधर भी वो स्वैपिंग का टेक्निक यूज किया है, सो दैट कि अगर वो एलिमेंट पिवट से लेस है तो उधर वो स्वैप हो जाएगा और हमको वो स्मॉलेस्ट एलिमेंट मिल जाएगा। बस यही लॉजिक है स्वैपिंग का। सो अभी ये सॉल्व करो, मतलब क्विक सॉर्ट यूज करके करो स्टेप बाय स्टेप, और वो ग्रुप पे डाल दो। और याद रखो जो टॉप 3 होंगे उनके नेम्स हम नोट कर लेंगे, मतलब बाद में वो बेस्ट परफॉर्मर्स के लिए। सो ट्राई टू सॉल्व फास्ट।
Yeah, guys, if you have any doubt, just right now. Otherwise, मुझे रिस्पॉन्स चाहिए सबका. I need the pictures. I need the solving. I'm not seeing them in the groups. One person has sent it. Yeah, like the Bhagyashri Mehere sent it. That's how it should be. That's how you should like solve it. That would be easier. Quickly try it, guys. We'll be moving on ahead.
जिनका हुआ है वो डन कर दो.
Yeah, after doing, can we take sorted are we first directly? I didn't quite get you, Sangameshwar. Can you turn on your mic? Can we take sorted are we fast to directly? Like what sorted are we?
सॉर्टेड एरे होगा तो वो पास से नहीं होगा ना. Output आ जाएगा.
Sangameshwar, can you like turn on your mic and explain? So I'll be able to answer you properly.
मोहित, ऐश्वर्या, विधि, सिर्फ 3 लोगों का हुआ.
Okay, guys, solve karo or send karo. It will be counted. If not the first three, it's not about that. अगर तुमने बाद में भी send किया है, फिर भी it will be counted. I told you it's all about consistency. लास्ट तक अगर हर चीज में पार्टिसिपेट किया है तुमने, हर क्विज में, हर एक्ट में, हर टास्क में, everywhere if you have participated, mostly if you have like participated in the meet or the presentation, that would be helpful, and that's what will be counted here. So yeah, so we'll be winding up with the first half, I guess. Yeah, Arpita.
या
So yes,
बस ये टाइम कॉम्प्लेक्सिटी ये ध्यान में रखो क्योंकि ये बहुत बार पूछा जाता है इंटरव्यू में. वीक सॉर्ट का तो पूछा ही जाता है, सो ये देख लो.
yeah, time complexities.
ये मेन है.
आज फर्स्ट हाफ की क्विज नहीं थी because she needed to give you some tasks, so like we utilized that time here. But I think we should have,
बोर हो गई.
never mind. We'll be having the quizzes afterwards as well. I think we need to extend the boot camp. If not covered up in this quicker. So yeah, give the claps for Arpita for the first half. She presented well. I think she deserves it. Yeah, everyone.
थैंक यू.
Yeah, that was a nice session, Arpita. You could stop now.
थैंक यू.
And about the task, guys, we need everyone to send it over there. Management team will be seeing you, counting the results. Okay. So yeah, we are done with the sorting techniques. Not all sorting techniques, but some of them which are extremely asked and which are easy to remember. So we have like taken them. Some of them might have been difficult for you by code wise or something like that. But guys, the code are like those are very easy if you have like yeah, तुमने अगर लॉजिक समझा है तो यू कुड टाइप. इट्स ऑल अबाउट लाइक क्विक स्टार्ट में क्या था, इट वाज द रिकर्शन. जिनको नहीं पता होगा उनके लिए थोड़ा डिफिकल्ट है, बट आई हैव एक्सप्लेन्ड यू दैट वाज. So after that it was a sorry, yeah, that was about the like recursion first. The quicksort was called again and again. Then it was all about the swapping functions, nothing more. So अगर तुम्हें लॉजिक समझ में आ गया तो लाइक स्वैपिंग फंक्शन तो क्या इजी था ना, लाइक शी टाइप्ड इट इन फ्रंट ऑफ यू, कितना इजी था. सो दैट्स व्हाट यू हैड टू डू अबाउट द फॉर लूप्स एंड एवरीथिंग. सो या जो बेसिक अभी तक सीखा था वही इम्प्लीमेंट करना था यूजिंग द लॉजिक. सो इट्स ऑल अबाउट द लॉजिक, डू लर्न इट. अगर तुम्हें कुछ समझ में नहीं आ रहा तो यू कैन आस्क इट. Your preferable language would be used and you would be taught well if you need it. Okay, so yeah, we should start with the second half. Her should be taken over there. So yeah, linked list will be started here. Yeah, Harsh.
Am I visible?
Yeah, start.
Yes. Just a second. Okay. My screen is visible, right? Hello.
Yes.
Just a second. Okay. Yeah. Hello, guys. Welcome again to DSA Bootcamp 2023. This is your host Harsh Duje. Yeah, you might know me. I have taken one session before also about polymorphism and abstraction. So without wasting time, I'll start with the session itself.
Hello, bro.
Hello. Hello. Okay, yeah, that was just hello. Okay. Yeah, let's start with the DSA Bootcamp itself. Before diving into the topic, let me be clear. This session would be code heavy, so you might need to code with me, or you can just take the notes and code it afterwards, right? So let's see.
Wait.
Hello.
Guys, is it just me or am I like you guys also like getting a bit lower voice?
Yeah,
थोड़ा
we're also getting lower voice.
yeah.
Just a
So,
second.
like, हर्ष थोड़ा सा like mic का issue होगा तो देखिए.
Hello. Am I audible? Hello.
No, you're audible but आवाज थोड़ी कम आ रही है. So
Please, I speak louder.
yeah, okay.
Hello. Hello. Is it okay now?
Yeah, it's good.
Okay, let's start. So before starting, I would like to introduce myself again. So here, let's start with linked list. So here's my introduction. I am tech enthusiast and I love to tinker around neural nets and transformers. I'm an open source fan, as I told you before also. And I'm always up for a nerdy conversation. You can DM me. So these are my socials. This is my GitHub social, Duce Hirsch. Then this is my LinkedIn social. I also write some hash note blocks. You can just check it out. It's code experiences. You can just check it out where I just document my coding journey and then some projects over here. It's a technical blog, so you can check it out. So before now, enough with the introductions. Let's start with the topic because it's going to be an extensive lecture. So buckle up, guys, and let's start and for the linked list. So what's today's agenda? Today's agenda is we'll start with arrays versus linked list. So what's the need of linked list? You may say that we have seen arrays, so it might be enough for data structures. So what's this new thing, linked list, right? I'll try to make you understand what's the advantages of linked list over arrays. Then we'll see the introduction to linked list with some explanation and code snippets. Then we'll try to create linked lists like single EW and circular. These are some types of linked lists. I'll explain it all in a very clear way. Then we'll have some explanation and code snippets as well. I'll code it real time, so you can have some interaction too. Then we'll end the session with some insertion and deletion and traversing. But however, solving questions might be quite extent. So I'll try to take them, but don't expect me to have these questions because it might get a quite extensive lecture. Okay, so let's start. Arrays versus linked lists. The choice between arrays and linked lists depends on your specific use case and the operations you need to perform frequently. Arrays are generally more efficient for random access and have less memory overhead, but linked list excels in situations where elements frequently need to be inserted or removed. So this just gives a review that you can use array where it's needed, and you can use linked list where it's needed. However, I'm here biased with linked list because I'm going to teach it today. So let's see some advantages first. This is an advantage that it is faster to insert and delete in linked list than arrays. So insertion and deletion is faster in linked list, and it requires a very less time complexity, that is constant O of 1. However, in arrays we need a n, that is a n of big O of n complexity there. So that is greater than linked list complexity. So that's a good thing about a linked list. And there is memory usage. Memory usage now, see, in arrays, array have a continuous memory allocations. Like after one element, another element is stored in a continuous manner. For example, there is an integer. An integer is stored in first index of an array, and in the second index, there is second integer stored. An integer have size of 4 bytes. So for example, the first element have one position as 1000, then the second element will have 1004. So it's a contiguous memory location, stored in contiguous memory locations. However, in linked list, the memory is allocated dynamically. Let's see, in arrays, we first have to define how much elements are we creating, how much elements should be given to space should be given to it, right? However, in linked list, there is no need to specify that how much elements we need right now. It allocates it dynamically. That is, it allocates it automatically for better understanding. Okay. Then there is size flexibility, the same thing. Then there is a usage. So just I explained in this paragraph that best case scenario for where the size is known and doesn't change often, we use arrays. When the best situation for this, the linked list, is dynamic resizing or frequent insertion deletions are required, then we use linked list. Then we have performance considerations. So there is a good performance of linked list when it comes to insertions and deletions. What does insertions and deletions mean? It means that when we just need to add an element in linked list, it's easier and faster rather than an array. Okay. So these are just some comparisons between arrays and linked list. Now let's start with our topic, linked list, which is going to be very extensive. Okay. First thing about linked list is a node. So what is linked list? Exactly, what is linked list? Linked list is just a chain of nodes. So this is called a node. So what a node consists? Node is like a custom data type. It consists of value as well as link to the next node. What does a link to the next node mean? Link to the next node means that this element consists the value of the element itself, right? We need a value for the element, obviously. It also consists a pointer which points towards the next node, which stores the location of next node. Okay, am I clear with that? Yeah. So let's see a Wikipedian definition here. A node is a collection of two sub-elements or parts, a data part that stores the element and a next part that stores the link to the next node. Yeah, quite basic. So here is a simple representation of linked list. Here we have one node, then it's connected to the next node, it's connected to the next node. The last thing which it is pointing to its null. That's the end of the node, end of the linked list. Okay, that's all about nodes. Let's dive deep more into the linked list mode. That is singly linked list. So what this singly means? It's a type of a linked list. It's a very basic and primitive type of linked list. And this is the code for the creation of node. I'm gonna do it in real time, so we'll check it out later. But for now, let's see what's next. So this is the singly linked list. So this is a structure. Now here we can see there are these two new elements, a head and a tail. So what are these? These are nothing but just pointers to the very first element of a linked list, and this pointer, the tail, is the pointer to the very last element of the linked list, which points to the null. Right? So head consists. Why does we have these elements? So for example, we don't have these elements, the head and tail node, which points toward these elements. What will happen? Let's see. This is a linked list we created. Now, how to access it? For accessing it, we need a memory location. We can't just memorize the link that is the hexadecimal code for the position of that element in the memory. So what we do is we create this reference that is head for the first element and tail for the last element for easy access. Okay, am I clear with that? Just give thumbs up if you're understanding it. Just okay. Okay, we have thumbs ups. Okay, okay. I'll just read it out. The singly linked list definition, Wikipedia definition again. Linked lists are particularly advantageous when you need a data structure that you can change in size dynamically, or when you need efficient insertions and deletions in your data structure, as I mentioned previously. However, it's essential to consider the trade-offs and specific requirements of your application when choosing between linked lists and arrays. So this is just a comparison that we need to just see what our application needs while choosing between linked list and arrays as our data structure, primary data structure. Okay, here is a meme. So you might know this Spider-Man meme. It's pointing towards next Spider-Man is pointing towards next Spider-Man. Here we have null. So I want to specify here. If you look closely, you can see that this Spider-Man is pointing to this Spider-Man, and this Spider-Man is pointing to this Spider-Man. However, this Spider-Man doesn't know who is pointing towards him, the behind one. It's like a simple example here. Yeah, this guy has a crush on this guy. However, this guy doesn't know that the guy behind him have a crush on him. So this chain goes on until this single guy who has crush on no one, but this guy have crush on this one. That's another part. However, this is the very significant feature where this node just knows about the next node, and the next node doesn't know about the previous node. In the singly linked list, we have doubly linked list which have some other rules, but for now just see this node doesn't know about the previous one. Okay, yeah, that's about linked list. I would like to just create a node here. So let's real code it. I'll just turn it into, yeah, I will just remind you that I created this package here. So we don't need to create a main package and then define the classes in there. So I just refactored the thing, and we have the public class here. And also, as I told in previous session, I'm primarily a Python developer, but the bootcamp is quite oriented towards Java, so I decided to go with Java here. So let's see. We created a LL, that is linked list, for example, linked list class here. This is the same thing. We can create it here also, like linked list class here, but I decided to make it in another file for more modularity and abstraction too. Okay, just for creating a node. So let's see, create a node. Let's create a private node so no one can access it directly. So what is node? Node is a data type, right? Like a custom data type. So how we define a custom data type? By creating a class of it. So let's create a class node. Class node. And what will it contain? So I need your questions here. I need your answers here. So what does that node will contain? I told you in the previous slide what a node contains. So what will the node contain? Just open your mics and answer. There is no need to open your start your cameras. I don't want to shoot up your anxieties or anything. Just try to speak and make this session more interactive. Anyone? Any essay students?
Value and address.
Yeah, great. Mohit gave answer that's perfect. That's right. Also, Kanchan Somani gave an answer, data and address. Yeah, very nice. So I need the participation of essay students too, my class students. So it would be nice. Let's see. I'll just pick one. Ayush Nikam, can you just open your mic? Hello.
Yeah, Harsh.
Yeah. So what would be the elements in this node? What would be initiated first? What the node contains? Hello. Am I audible?
Value,
Yeah, value and
link. I guess so.
Yeah, link. Link, that is a pointer to the next node, which points to the next node, right? So perfect, perfect. Nice, Ayush. So let's see, let's initiate a value. Let's create a private, uh, a private integer value. For example, we are creating a integer linked list. So we need, okay, we don't need this private here. So just we'll create an integer value here. Then we'll create a node pointing towards next. So if you know OOP, object-oriented programming, you will notice this is a self-referencing class. But if you don't know, you don't need to worry. Just think it in an abstract way that this is nothing. It just points to the next node. Okay, am I clear? It is nothing but it just an element which points towards next node, which stores information about next node and nothing else. Okay, that's it. That's it. Now, as a our tradition, we have to create some constructors. We don't have time that much, so we'll try to generate it from ID itself. First constructor will have input as integer, and the next constructor, let's generate once more. Next constructor will have these two as the as its arguments. So now, just for some interaction, I would like to know what type of feature is this. Here we are creating two constructors with same name, two member functions in a more high level way, two member functions with the same name. So what feature of OOP is this? Just answer.
Function overriding.
Okay, okay. Mohit is answering all the questions. That's really nice. However, I need participation of others also to make this session more interactive. Anyone? So what feature is this? You can just tell what it's in a high level format, like he told it in a very specified way. Okay, function overloading, it's overriding. Okay, okay. So that is the function overloading. That is member function overloading. Here we are overloading these two. The concept is of polymorphism. For high level ideas of polymorphism, that we can use two same function names in this class itself for with different arguments. So that's function method overloading, right? Or we can call it a function overloading in a more abstract way. Okay, we have created these two constructors. So what these two constructors we do? If we created a node, it's compulsory we have to compulsorily insert an value for it. Otherwise, you can also use this next function, that is a value of next node. We can also assign it to it. So that's it. We have created a node here. Yeah, that's great, right? We have created a node. Our very first step to learn linked list. The building blocks of linked list is node. So we have created it. So it's very nice. Now we'll see some functions. Before that, question, like, we have just created node, but we need to specify two more special nodes here. We have to declare them. So what are these two special nodes? Can anyone answer? No.
The question repeat.
So we have to create here two special nodes. We have to declare two special nodes here. I have mentioned it in presentation. Which are these two nodes? Those are referencing nodes. They are referencing to some nodes in the linked list. So these are some special nodes. So which are these? So the answer is in front of your guys, in front of your eyes, bro. So that's a fumble. Okay. Anyone? Hello. I guess head and tail. Yeah, yeah. Right. Mohit. So Mohit is giving all the answers. I expect others too giving the answers. Okay. Let's not let down our morals and start with it. Let's create some nodes, special nodes, that is head node and a tail node. Second. Yeah. yeah, we have created this in private because we don't want anyone to access it directly from our function, from our class. Okay, now we are done with creating a very basic primitive boiler code for linked list, right? Now let's move ahead and see some functions which we need for creating a linked list. So what's the first function? What do you think? The first function might be creating a first element in the list, right? We have just created these nodes and these abstract things, but we need to create a linked list and just add some nodes to it, right? For that, we have to create a function which is available to public. So how we can do it? We can just create an inserting element. So what we do is create a insert first member function, and then I'll try to explain it in animation. So let's see, we have a linked list here, right? We have a linked list here with a normal simple linked list with head over the first thing, that the first element. Tail is there, you can't see it, I guess. So yeah. So what we'll do, now we have to create a node just before the first element. So this is the function which will allow the user to create a node before the first element, just inserting it before the first element. So what we'll do is we'll just create a node first, right? Without any linking it to anything, we'll just create a node here. Yeah, we are defining a node with a new node with the value assigned by the user. We created this node. Now just link this node to the head node. And the last step, that is, we have to just remove its head and assign it to the new node. That's it. And yeah, here we created we inserted our first element in our linked list. Pretty cool, right? So let's see the steps again. Create a new node with given value. Point node.next to head first. So node.next means the link value. Just point it towards the head. Head means this thing, the previous head, just point it towards it, and then change the head position to the given node. Quite simple. You have to remember that before changing the head's position directly to this element, we have to link it first with the head position. So why I'm saying this? It should be sequentially right, because if you don't do this, if you don't link it with the next node, there is no way to access it, because the referencing thing is head, and the only referencing thing is head. So you have to link it first and then move the head. If you move the head first, there would be no possible way to just link it to the next node. That's it. So let's code in real time. So we have created a node here. I'll just minimize it, and create the now insert first function. So it should be available to public. We'll return a void type insert. Let's name it insert first, because we are inserting in the first element.
Hey Harsh.
Yeah.
Yeah, Prapti had one question. If you could explain it.
Okay, sure, sir. Both elements have same value. Does it matter? Okay, it doesn't matter. Just like arrays, if you have two elements the same value, it doesn't matter. The links are different, right? So the elements are different. There is no connection between the link and value of that node itself.
I think so. Harsh, she's asking about node.
Yeah,
what she have mentioned that nodes. I think so. She's asking about node.
Okay.
If it's about the nodes, the two nodes won't be having the same address, right?
Yeah,
because the memory stack, they'll be having some memory allocated to them, right? So same memory can't be used by two nodes. It'll be created differently. So yeah, the values can be same. The address would be different for each node that we are creating. And also guys, for linked list, we are creating it itself, like we are creating the data structure. So it's a bit like vast concept. So try to understand. The lecture might extend some like for a few minutes. But if not covered today, we can continue if you don't understand it well. So it's about the understanding. Do listen to him and do try to understand the logic
So you could implement it. Okay. I'll continue. So we are talking about inserting it in the first element. We were creating the function here. So for inserting the element first, what we have to take as an argument, the value. Without value, there is nothing we can do. We have to just take value from user. So what value should be there in that node, right? Now, as a creating a node, let's name it node itself with a small n, and now a new node, a keyword node, and here we have to pass, as we have constructor value, we have to pass the value which we have taken from user. Okay, that's it. We have created a node. Now,
Harsh,
yeah.
can you once recheck with your internet connection? It's like sometime it lag in between, and your voice is also breaking. So just
Okay.
check it once. Otherwise, you
Just
can continue.
change my network now. Hello.
Yeah, the voice is clear now. You can continue with the presentation.
Okay, yeah. We have created a node now. Now, what we have to do is, I told you that we need to first reference this node's next element. What is next element? That is the link of this node. So link of this node. So link of this node should be pointing towards the old head. So we'll just update that value. Node.next is equal to head. So it's now linked. Now what we have to do is, we have to just move this head to this pointer. And that would be easy. We have to just update the heads value to this node. And yeah, we are pretty much done with it. However, there is an edge case. What is an edge case? For example, there is no elements in linked list. It's totally null. That is, if we have tail, just a second, if you have tail equal to null, that is, there is no element in the linked list. What we have to do is, we just want to assign the tails value to head, right? So I'd like to explain it on a whiteboard. So let's see. Okay, so this is the node, and this is a linked list, for example. And if you have a null linked list, that is, there is no element in the linked list, what we can do is, we can just if we inserted a first element here, we'll just point the head position and the tail position to that element itself, that node itself. So that's it. That's the edge case here. Okay. So let's see how. Yeah, it's implemented here. I forgot to mention that we'll also maintain another variable here, that is size, because we need to maintain a size of the linked list too for transversing or any other things. Let's create a variable size which will just store the size of the linked list. So here we created a variable size, and after insertion we'll just increase the size by 1. That's the operator. Okay, yeah, we are done with creating the first node here, that is by insert first function. So we can implement this function. However, we can't see the results yet because there is no display function created till now. So we need to create a display function. For that, we need to learn about traversing through the linked list for displaying each element in linked list. Before that, I will also need you to understand. So this is just a small animation of inserting in the beginning. So let's see. Yeah, it's inserted here. We just moved the position here. And yeah, we have the first element. Okay. Now let's see how can we insert the element to the last position. This is just a small me. As I told you that this guy have crush on this guy, like that. I know a guy who knows a guy. The chain goes on. It's like that. That's like the linked list data structure. Okay. So this is linked list, a normal linked list, as you can see. So here we have a tail element here. That is, last element is a tail. Now what we have to do is insert a element, a node, for example this node, to the last position. For that, what we have to do? So any guesses? Anyone would like to answer? Hello. How can we do that? Just you can explain it in a vague way. It's okay if it is wrong. So you might get some idea, right? After inserting it in a first position, I have told it very clearly, I guess. So if you are clear with that, I guess you might have an idea how we'll implement this. So anyone? Yes, no one is. Am I audible? Hello.
Yes, you are. Yes, you are.
Okay. I guess no one is interested then. Okay, we'll just move ahead. No problem. Yeah, we created a node here and we want to insert this node at the last position of the linked list. So what we'll do is we will first make this last elements next pointing towards this node. So what we'll do, we'll just get out of this null thing and just point this elements next to page4, which was previously pointing towards null. So we'll just make it point to the new node. And then what we'll do is we'll just change the tails position. Just like we did in head, we have to just change the tails position. Quite simple, right? If we didn't had the tail element, what we had to do is we need to traverse through the entire linked list and then we have to access this. So it would have a larger time complexity. It would be not optimized. So tail element is very necessary here. It will just it will do the work in the constant O of time. So it is very advantageous over arrays. Okay. So now we'll just try to implement this in code. Okay. So let's create. So I'll hide this first. Create another member function. Let's see, public will return a void type just like insert first. Now we will create an insert last function. We'll take integer value 2 for the node creation. Okay, yeah. Let's create a new node first. We're creating a new node first. Node. Let's call it a nodes with a small n. Again, create a new node with that value. If you know Java, this might be familiar. You might be familiar with it. Otherwise, other snippets are going to be shared. You're going to get those snippets on your GitHub repo shared by our Krishna, our team lead. Now, what we'll do is we have created a new node with the value given by the user. Then what we can do, what we have to do, see the link of the last node, this node, the tail node, we have to refer it, we have to point it toward this new node. So what we'll do, it's simple, we'll just create do tail dot next. So tails next would be pointing towards this new node. So this new node is equal to node. Pretty easy, right? After that, what you have to do, let's see. Now we have to just change the position of tail. We have to update the position of tail from this element to this element. That is a new node. For that, update tail equals to this new node. Yeah, we are done with this. Now again, there is an edge case if there is nothing, no link, no element in the linked list. So what we'll do is we'll just create a control statement, if control statement, with the condition that is if tail equals to node. Tail equals to null. What we have to do is we'll just implement the insert first function. That would be easy, right? So we'll just call insert first function with the value given by the user. Yeah, we are done with the insert first and insert last functions. So these two functions are easy. Now we have to display these functions. We have some we need some output, right, for proof of work. Is it working or not? Okay. So for that, what we'll do is we'll create and display function which will also teach us how to traverse through the linked list and get any element we want. So for that, so this is you might want to see this animation too. Insert last. Here we are using traverse method for inserting. And we can use tail method too. Just now I explained it. Now then, so inserting in a any specified element, this would require. So it's nothing but first we need to understand the concept of traversing here, and then we will move towards this insertion. So first, let's create. Let's see. When linked list ends, iterating pointer be like next node बोल के null में खुदा दिया भाई. Okay. So what does it mean? Let's see. So while traversing through a linked list, what we can do? So let's see. We have an let's say we have an linked list here. This linked list. Just a second. Okay, we have this linked list. Just focus on this. Now, for traversing, what does traversing mean first? We just want to access every element of this. We have to go through the linked list entirely. So for that, what we can do is, let's see, if you move the position, there is only one way to access element. That is, we have the reference first element, that is head. Okay, we can just update the position of head element to the next position, to the next position, and just get its value. Okay, that would be right, I guess. But no, what happens here is if we just update the position of head to the next and access that element, it will work for the first iteration. But after that, the head position will become entirely changed, and it would be like on this element, for example, it's assigned to this element. Then the elements behind this element is not accessible. The entire data structure changes, and we'll get an absolutely different data structure here, and these two elements would be inaccessible, and which is very I guess which is a wrong thing to do. And let's see how to do it properly. So to do this properly, what we have to do, we'll create a temp node. Just like head, we'll create a temporary node. See, I want to say is, so we'll create a temp node. So let's call that node as node, or we can call it temp. And then what we'll do is we'll just assign its tails value to the head. So head would be completely different from that temporary node. It would be just equal to that. The temp variable's value would be equal to that head's variable, head referencing. Okay. Now what we'll do is we'll just like head, we'll just change that position of temp by temp.next. We'll just update that position till the null occurs, and that's it. We have traversed through an array with the traversed through a linked list without any damaging the data structure. And what to do about the temporary node? We don't need that, so it would be collected after this with the garbage collector by Java. So let's try to create that transversing element. So let's see. Let's create a public display function. Public void display. What will display have arguments like? It would not have any arguments. Okay. What we'll do is let's create a function, and now we'll create a temporary node. That's, let's call it a temp, and assign its value to head. I mean, let's assign the value for it as head. So it would be on the first position. Now we have to iterate. We have to go to the next position for transversing. So for that,
Harsh,
hello.
we have one question here.
Okay.
By the way, if you ask any question in the chat, no, just like raise your hand so that he'd be knowing that.
Yeah.
He's not getting any notifications, so.
So do we need to mention that the last node is pointing to null in the program? No. If we have studied OOP, we just created these two special functions which didn't have any value. We didn't create any constructor values there. Any arguments are not passed there, so it will obviously point towards null automatically. So I think it's clear. Okay. It will directly point towards null. It's obvious. Okay. Great. So let's see now. We were seeing the display thing. So yeah, here we created a temp variable. temp node. I'm sorry. We have assigned it the head value, so it's on the first node right now. So for traversing, let's give a condition over here. What's the condition? For traversing, let's see, until the temp does not equals to get equal to null, is till then we'll just traverse through this array, traverse through this linked list. I'm sorry. So for that, and now we have to also give the output to the users. South. South is for printing anything in Java. What would be here? Temp would be here. Temp dot value would be here. So we don't need to give a link value to the user. We just need to show the temporary nodes value directly. So no need to give a links value there. And also let's have some arrows here for representing the next element, the next thing in next node in linked list. Okay. Now let's see. For this is done, but what we have to do is we have to give it a statement so that it can iterate and go to the next pointer. For that, what we can do is we'll just update the temps value regularly until it becomes null. We have to just update the temp value to temp dot next. So it will just go to the next element until this condition is reached. Okay. Yeah, that's it. Then we'll just create an S out for knowing that that's the end. Yes, we are done with creating a display function. So these three functions now are done. We are done with these three functions. Now what we can do, we can just try to print the linked list here. So I'm just shifting to the Java thing. This is the main function here. So you don't need to panic here. It's just normal. You can write this code on this file too. However, to make it modular, I am doing it in this way. Here is, let's create a linked list first. Linked list. For creating a linked list, like any other class, we'll create a linked list. Let's name it list, which should be equal to new linked list. We don't need to pass any variables here. Okay. A linked list object is created here. So let's use our function C. So for very first time, what we have to do, let's use insert first function. Let's insert some value like 23, more values like insert first. Let's say 34. Just try to copy paste it for saving time. Let's 43. Anything. You can assign it anything. 57, 65. Okay. So yeah, we have created some elements here. So what do you think? What would be the sequence of these elements? This might be quite tricky. So let's see who is right. So anyone? What would be the sequence of this? How would it be printed? So it would be like a 23, 34, 43, 65, or 65, 43, 34, 23, or any other thing.
65 say 65 65 43 34 23.
That's right. Perfect. So let's try to display. So let's see what prints. So let's run it. It's building. And yeah, what happened here? Let me check. I guess. Oh, I think there is an error. I'll just try to see what happened here. Insert first. Tail is null. Tail equal to head. Just a second. Let me check it. Node dot next is equal to head. Head is equal to node. Okay. Yes, it should not give this error. Let's check again. Schema till null. Temp dot value is printed here. Let me just try to run it again. This error should be not going.
Just plug in your laptop. It's gonna be switch off.
Okay. Just a second. I guess there is some error. Yeah, I'll just check the code here for displaying. Tail is equal to head. Sorry, excuse me. There should be no error here. Okay, yeah. While temp is not equal to null, I guess. Yeah, that was the wrong condition here. Well, temp is not equal to null. We have to print this. Therefore, it was exiting the loop. And I'm really sorry for that. There was just the small change that we have to do. That we just have to assign it that if temp is not equal to null, till then we have to iterate. We did it completely opposite. Okay, now let's try to run this. I'll just pray to God. It will run. Yeah, it's running. It's running again. Let's run it again. And then, yeah, that's it. So that was a small iterating mistake. Sorry for that. But yeah, we are able to successfully run this and display this linked list. Okay. Now let's try to insert it on the last element. We also created the last insert last function over there. So let's try this. 43 list dot insert at last. 63. Now where these elements should be placed? At the very last of the linked list. So let's try to run it again. Yeah, it runs successfully. Okay. So that was about creating insertion and traversing to the linked list. I guess what's the time? It's 8 already. So I'll like to make it quite fast. So let me see. So this is the insertion. This was the traversing. So deleting would be the part of the traversing itself. So you can figure it out later. But I need to just what I have to do is I have to just make it a fast-paced session now because we have to wrap it up quickly. Okay, let's see. This is a small meme. I wanted to explain it, however, there is no time, I guess. We did this right now. It was in just a meme form. So remove the first node from linked list, delete second node after becoming head. कभी-कभी लगता है आप उन्हें भगवान हैं. Yeah, that was a meme. So let's see. Now let's move forward directly to doubly linked list. I didn't thought that it would be this long. Okay, let's see. What's a doubly linked list? Just like a singly linked list, doubly linked list is nothing but a quite similar linked list with a just a different with a just an extra parameter or extra variable here. Let's see. So in a doubly linked list, how its node looks like is there is a value, there is link. However, this link have see this node. For example, this node will have the that is the value for the link of the next node also, and this node will have the value for the previous node also. Now the crush that the next guy also knows that the previous guy have a crush on him. So that's the perfect thing to explain here, I guess. So for that, here is the node of an DLL, that is doubly linked list. Okay, we have a question, I guess. No. Yeah. Where were we? Okay, So how we implement a doubly linked list node? So implementation same as singly linked list. Just a new node object is declared here. That is pref. That is the link to the previous object. So that is also stored in the node. This eliminates the need of tail because we can traverse through it backwards. Okay, so we will single linked list. Let's see what's the difference. We have a simple doubly linked list. Here, this node is connected to this node, and this node also knows that this node is connected to this node, and the cycle goes on till it eliminates with the null, terminates with the null. Let's see, we have to add an element on the first position of the linked list. So what we have to do is we just created a node here. Here, this is the node we created, and it's not linked to anything right now. Then we'll just link its next to the head and heads previous to the new node. So quite confusing, right? I'll explain it again. This elements, see, this is a new node. What we have to do is we have to link its next value to the head value and the head's previous value to the new node. So now I think you might get it. If you don't, I would recommend you to just go through the code. You might understand it. It's a very easy code for implementation. Okay. After this, as our regular ritual, we just move the head to the first element. That's it. For creating a new node, this is the steps. Create a new node with given value, then point node dot next to head first and node dot previous to null. So what we are doing, why are we doing this first? So there is a sequential thing I told you previously also. Why are we doing this first? Because if there is no head here, there is no possible way to access this element directly. Okay. So first we have to do, we have to link it with the head, and then we have to change the position of the head to the first element. That's easy. I think doubly linked lists real-time code. I think it's not possible right now. I plan to make it a short video, a short session. I guess it's not possible right now. So let's move ahead with the insert last function. There is no a major difference in this. We just have a new thing, that is a previous variable here declared in the node of DLL. Let's see here. We had in singly linked list, we had just value and the next elements link, but we also have a previous elements link in this in this node, this special type of node for doubly linked list. So we created these two constructors with the value and then with these three arguments. Again, the method overloading here, and then we learned about the insertion in the first place. Then we'll see the insertion in the last place. It's same like the previous thing, that is for the singly linked list. Here we have a linked list again. Now what we have to do, we created a node. We created a node, it's in air right now, for example. Then we'll just point the head, we just point the tails next to this new node. Then we'll just point this new node's previous to the tail. Yeah, the connection is made. Now the last step, we just need to change the null's tails position, update the tails position to the new node. Okay, and it's done. Yeah, we are able to add a last element into this linked list. Similar to a singly linked list, just we have to assign the previous value of this to the tail after assigning the first, that is next value of this element to this. Okay. Now we'll see circular linked list. Let's dive into it. So circular linked list is like this. The major difference is that the circular linked list does not point to null. No node of the circular linked list points towards null. The last element of the linked list, that is this tail, is directly referring to the pointing towards the head, that is the first element of the linked list. So this is the circular linked list. See, so I have just compressed this. It's same like the singly and doubly linked list. However, there is just quite different updates here. Let's see. So we are creating an insert first here. Node would be same, right? For the singly linked list and the circular linked list, node would be same. There is no previous element here. So node would be same. Let's directly see the insert first thing. We create a new node here. Then if the heads value is null, that's this is a edge case, but the edge case is different now. If the heads value is null, what we'll do, we'll just point the heads value to node and the tails value also to the node. Pretty easy. Why? Because both the elements, if we are just a single node, if you are just a single node, I am not able to draw here. Let's check the whiteboard. If you are just a single node in circular linked list, pretty bad drawing. Okay, let's create a shape. That's a single node, I guess. Let's see. And now we'll just point this node's head to the tail. What would be it would look like this. Easy. Then there is just a single node here, so the head is pointing towards the tail. Okay, both head and tail is pointing towards the same thing, so it's a single element in a circular linked list. Okay, let's see. There is also display here. Display is quite same. However, we just need to iterate it with the size thing, so that we don't get in a loop, because there is no null for specifying the endpoint of the loop. Like base condition is not there for specifying the endpoint of the loop. So what we do is we use here the size element which we created in the first linked list session. Okay. Then insert last is the same thing. However, the first we have to just change these values. This is the new thing, update here. So yeah, these are some visualizations in a circular linked list. So let's see at the beginning. I'm sorry. So in the beginning, so this is some visualizations. Yeah. Then we have at the end how we add it in the end like this. Then we have a deletion thing. So these PPTs would be provided. These are just GIFs, so you can directly access them. There is no need to worry. Then, yeah, this is a meme of a circular linked list. So this is the head, and its tail is pointing towards the head. These are just dots, which are signifying the continuation of the linked list. Okay, I think that's it, and that was a very fast-paced session. The last element of the session would be, of course, the quiz. So let's directly dive into the quiz. I think. Let me just share you the quiz link. Just a second. I'll stop presenting now. Just okay. Okay, where is the link?
Okay, before continuing to the quiz, आज का सेशन हैवी हुआ क्या? एक बार थम्स अप या हैंड रेज दे दो.
For those who are learning, उनके लिए थोड़ा हेवी ही होगा. जो नहीं सीख रहे उनके लिए नहीं होगा. As per me.
I'm sorry, guys. Like I was not able to complete properly, so because of the time restrictions. If time permits, next time if there is this any.
Yes, sir. Surely. If you have any doubts, guys, like Harsh might have covered everything today in today's session, but it was quite like a good session, right? So have applause for him. Give him a like, yeah. Let him praise some. Okay. And also, if you have any doubts, you can ask Harsh or me personally, and I'll be having your doubts clear by Harsh himself or otherwise me. And that's about today's session. But yeah, they're left with the quiz, so we'll be starting with the quiz. Go to the quiz. We have shared the link over there. And about the person who is going to solve for today, is there any volunteer today? Guys, you are like streaming on the YouTube, right? So you need to flex some. So you could share the screen and solve the quiz. It's not about the accuracy, it's about the participation.
अभी सीखा है तो आई एम नॉट एक्सपेक्टिंग यू टू लाइक स्कोर आउट ऑफ मार्क्स इन द क्विज.
Questions should be easy. Questions should be easy. So
Yeah. Questions are easy. So let's start.
Okay, I think there are less participants. 9 participants only.
No, there should be 40. Guys, go to the quiz. It's important. Quickly खत्म करो so that तुम्हें भी जाने होगा, मुझे भी जाना है obviously.
खाना खाते खाते क्विज दे ही सकते हैं सब. चलो, come on, come to the link.
Hey, bhai, बहुत easy questions. Just try.
Quickly, guys, go to the link. Start with the quiz. And do we have any volunteer today? Anyone hand raise कर दो. If you could volunteer.
हेलो हर्ष, 8 है ना, तो 30 से पहले मिनिमम 25-30 होगा तब चालू करें.
Yeah, sure.
Okay, I think.
हम ही नाम कॉल कर लेते हैं इसके लिए, स्क्रीन शेयरिंग के लिए.
या वही करना पड़ेगा. क्या यार?
Okay, 50
participation. Yeah, Prati has volunteered. He had shared in yesterday, na? Okay.
Ainik, who's this new guy? इसको बोल सकता.
Boy or girl?
I never heard his or her name.
हाँ, unique name. सही है. Yo, Anik. Yeah, done.
अच्छा, आयुष निकम. He's आयुष निकम.
Yeah, okay. You bro, you could share your screen and start with the quiz.
He changed his name itself.
How many people are there, Harsh?
No, that's actually my another account.
Only 17 are there.
There are 18 right now participants. I guess there are 37 people here, so everyone just participate.
छोटा सा क्विज है और जल्दी फ्री हो जाओगे तुम लोग. Come on, give us the count of 25. Quick.
It would be easy. Just use Google for signing.
अबे सारे बच्चे जाओ जल्दी, जो यहाँ पे काम कर रहे हो भी. Yeah. Final year students as well. Everyone should go.
Till 19 participants.
Dev team तो मुझे पूरा चाहिए, ठीक है?
Directly use sign in with Google, आयुष. हमेशा ये
password-
करने की जरूरत नहीं.
Just sign in with Google. It would be quite easy then.
ये ऐसे स्पीडी टिप्स एंड ट्रिक्स ना टेक्नोलॉजी के लिए जान लो. साइन इन विद गूगल, ये सब जो वन शॉट होते हैं ना, वन क्लिक होते हैं, इन सब का इस्तेमाल किया. क्लाउड के वक्त भी मुझे बहुत लोग पूछते थे यहाँ क्या डालूं वहाँ क्या डालूं. जस्ट क्लिक द साइन इन विद गूगल. इतना अच्छा ऑप्शन दिया है गूगल ने, व्हाई वुडंट वी यूज इट.
Okay, one more participant added. I think that was Ayush. So 20 participants total.
Yeah, you should start the quiz, Harsh.
Okay, I'm starting the quiz. The first question should be on your screens in 3 seconds. First question: what is linked list? Yeah, I think that answer should be given because I don't think that the session was that bad. Don't refresh.
Joined late. Don't refresh. I mean, how wish I were. You
If
came
you
late.
miss the question will be gone because it's a live quiz. So just don't refresh the quiz. Okay, 84% have given the right answer. So let's move to the next question.
Yeah, wait, Harsh. Let Ayush join.
Okay, I'm sorry. I guess I started the next question.
Let it be, भैया. Let someone else do it. Share it.
Yeah.
Okay.
Abhijit, can you? Abhijit, चल. ये अपना ये है ना प्रेसिडेंट है शायद.
Yes, yes. The second question is, what is the first node in a singly linked list called? So this is very easy.
Abhijit, can you share the screen?
So Abhijit is the first one in the leaderboard. Okay, 100% students gave it right. It's fine. Okay, let's move to the next question.
तुझे ही आना पड़ा शायद. Sure.
हाँ
In a singly linked list, how do you access the last element efficiently?
So I have talked about this in a.
Yeah, Harsh have mentioned this one, so and also Mohit. I told you not to like
हाँ
answer.
हाँ वो अब वो लास्ट में वो 2 दिन से किया नहीं ना तो रिफ्लेक्स में निकल गया.
नहीं अभी तेरे को मैं डिफॉल्ट बनाएगा.
Okay, leaderboard is updated. Abhijit on first position, Mohit on second, third Nikita, fourth Mayank, fifth ICOER, and sixth Neil.
लास्ट में आंसर देने के चक्कर में लीडर बोर्ड नीचे चले जाता मैं.
हाँ नहीं मतलब कोई नहीं. मोहित फर्स्ट है ठीक है.
Yeah. Let's move to the next question. Yeah, in 4 seconds, the next question. What is the time complexity for inserting an element at the beginning of a singly linked list? So you can analyze this.
So easy.
We created just one function there, and just think what that function consists. Does it consist a loop? Does it consist anything just like control statement? And just try to analyze it and give the right answer. Okay, only 32%. Okay, that's not that bad. Okay, let's directly move to the next question.
अरे मोहित चला गया नीचे.
Mohit on third position right now. Sanika making her way up. What is doubly linked list? Easy question. Just try to remember what was the difference between the singly linked list and doubly linked list. Just there is one difference. Try to remember that and answer it properly. Mohit making it more suspicious. Okay, yeah, we have.
ज्यादा सस्पिशियस हो गया आंसर करना ही भूल गया. इट वाज सी.
Okay, right. Let's make it. Let's start with next question. The leaderboard right now is reading Abhijit, then Nikita, then Mohit, then Sanika, and Mayank. Okay, next question. At last, leaderboards would be totally different. It would be which of the following is not a common variation of a linked list. So now this answer should be given because those were the sub-headlines of the presentation itself. Leaderboard, it's updating.
Which of the following is not a common variation of a linked list? हाँ अभी जितने हुए उनको छोड़ के आंसर.
75%. Abhijit still maintaining.
26% कहाँ मर रहे हो? Seriously? It's getting up.
Okay, now let's move to the next question. 7th one.
And go.
What is a node's next pointer in a linked list set to if its last node in a singly linked? If it is a last node in a singly linked list. So what is the last node's pointing to? Last node is
इस
pointing
पे
to.
क्वेश्चन भी आया था guys, if you remember.
हाँ, right.
I think प्राप्ति को ये बराबर आएगा. Solve कर.
Leaderboard is changed. Nikita on first, Sanik on second. Abhijit moved directly to he's directly to fourth position.
And yeah, प्राप्ति had like fourth position पे आ गई हो.
Yeah, that was quite fast. Now let's move to the next question. Coming up in 4 seconds. What is the main advantage of a linked list over an array when it comes to inserting elements? This was also discussed in the first slide itself, the very first slide. Leaderboard is changing quite dramatically. Mohit again on first position, Nikita on second, third Prapti, and then Sanika.
भाई मेरा टाइम देखो.
Great, great. let's move to the next question. So ninth question.
आई थिंक किसी ने आंसर गलत कर दिया. अभिजीत नीचे चला गया क्या?
Yes, yes. Abhijit is on, I guess, seventh position. So ninth
It's
question
getting interesting.
is yeah, leaderboard is changing quite dramatically. That's right. In a circular linked list, what is difference from a regular linked list? What is the difference between a circular and regular linked list?
The time was quite short, but still हर्ष ने mention किया था क्या difference होता है.
Okay, still 63%. Okay.
Yeah. Mohit,
Okay, the last question. Like every time, this is a bonus. So let's see what's the last question.
this accuracy is like heavenly.
Why did the linked list break up with the array? First is because the array kept trying to index into the relationship, but the linked list just want to node things. The second question is why matters. What do you think?
I think both answers should be correct.
Yeah, we are Gen Z generation, so
Vibe matters. Vibe matters.
yeah, vibe matters.
कुछ लोगों के लिए राइट ज्यादा इम्पोर्टेंट रहेगा, ठीक है.
देखते करके कुछ.
40% जेन जी है. नहीं गाइस, तुमको भी मिलेंगे मार्क्स, ठीक है इसके.
Yes, yes. You did not need to worry about this. So yeah, we are done with our quiz. Let's see the leaderboard. Go to the leaderboard. See, Mohit is on first position. Then Nikita Chaudhary. Then Prapti Bargir. Then Sanika. Then Abhijit. Abhijit moved to directly fifth position. Okay. Then Madhura Mari, the SE student. Mayank is also there. So these two SE students are there. Mayank Badgare. Then Mruganka Chiplunkar, then Aishwarya, then Aditya Tote, and the list goes on. These are the top 10. Okay. So, yeah, that's it. And
Nicely played, guys.
I want to just apologize for the session because I know it was not enough for the like completing it. The time was also very less. But okay, that's it. And this is your host Harsh signing off. Thank you.
Like personally sharing, लिंक लिस्ट की थियरी सबसे बढ़िया थियरी है पूरे डीएस में. उसका एप्लीकेशन बहुत डिफिकल्ट होगा गाइस, बट थियरी बहुत अच्छी थियरी है.
So guys, do I need to mention that it was a great session, or would you like applause for him and let me know? Yeah. And also for Arpita, both Harsh and Arpita had explained well, and they did a good thing. As of today, we are completed with linked list and arrays, and also searching and sorting. Someone did raise a hand. Who was it?
I guess Shantanu was there.
Do you have any doubt or something? Well, I'm moving towards that. If you have any doubt, guys, like hand raise कर दो. Sorting it out. इतना सारा सर्चिंग सॉर्टिंग हो गया तो चलो डाउट सर्च करते हैं एंड सॉर्ट भी कर देते हैं. Yeah, quite good. So okay guys, yeah, we are done with the today's session. I'll be sharing you the feedback form. So go fill up the form. Management team है ना यार. Otherwise I'll be
अरे feedback form, yes, on the way.
Yeah, okay. I'll spam the feedback form. Go and fill up it, and let me know the like how should we improve or anything. Guys, कुछ improvements है, recommendation है तो be welcome. Those, yeah, go and fill up the form and yeah, we'll be off. किसी को कोई
Bye
doubt
bye,
या
guys.
कुछ बोलना है तो बता दो अभी. If you have any feedbacks or something like that. I guess no. So yeah, बाय तो बोल सकते हो माइक ऑन करके या फिर चैट में डाल दो. चलो, नाइट गाइस.